Lots of progress this week. I am getting down to the, like the song says, the final countdown. When it comes to problems, I was able to work through the rest of chapter 12, which sort of surprised me. I thought it was going to take me longer to try a few problems, but I did not try many of the hard problems. I want to get through in this reading cycle, and so I'm only doing enough problems to get through the basic understanding of the subject, and then there'll be another. I'm planning multiple rounds, as I keep saying. So yeah, this week I worked through a few problems in chapter 12. I was pleasantly surprised that, incredibly enough, the derivatives, the r to the n differentiation chapter 11, turned out to be harder for problems, at least the ones that I tried, than 12. And I think it's because of power series and Taylor series, especially Taylor series and r to the n. And then when it came to the gamma function, I was very pleasantly surprised that the first two problems that I tried, I got both of them right in like a matter of minutes, which was very surprising. So that's great. But on the flip side, the double and triple integral problems, I got some right, but I know I did what I consider to be a poor job on these problems. And it's one of these things of, I need to go back and really polish my double and triple integrals from calculus. It's been years, and yes, I can do all the simple ones fairly easily. Anybody can once you know the rules. But when you get into like all sorts of tricky substitutions, understanding the geometry of the problem, I need to go back. This is a redo, big redo. Then when it comes to reading chapter 14, very interesting. I love Fourier series, and so I've been reading through it. I'm almost done. So I think next week I will already be reading the last chapter of the book, chapter 15, which is short. So I'm really towards the end as far as finishing the reading. I would expect that by the end of June, I'm hoping, in the next couple of weeks, I'll finish it. Then I'll do a few more problems. And then I'll set out to do some planning for the summer. When you do self-learning, you do all your planning, which is good and bad. All right, so I read, again, 3 middle sections of chapter 14. This does not, it's not measurable in even spaces. This was actually not a lot of reading. I did more problems than reading. Now, I did all these problems, did. I think in some of them, I gotta go back. I gotta go back in one of my future cycles and really do all these other problems. This is really where the meat of this book is really in, to fully understand the concepts. And I have to go back. So now I already laid out the remaining chapters, 13, 14, 15. See how short chapter 15 is? And so there you have it. And I'm going to show the actual work. So yeah, now this notebook's getting a little thicker because I added chapter 13 reading. I worked on some Jordan region problems. Took me a little bit to figure it out, but I did in the end. And then some of the integrals, trying to draw them. Some were easy off the bat, and others I kind of got stuck on and took me a while. One of them I actually punted. I don't believe I got it right. It's this one. It's a triangle. It's a triangle in three-dimensional space that hooks to the corners of 3, 3, 3 and x, y, z. X plus y plus z is equal to 3. And I figured out that I was doing it wrong just by thinking about a case of where I only do the little cube. And I realized that I was doing it wrong. I kept thinking that the volume of the entire triangle was 27 over 8. But it's not, because when you take just a single cube, which is actually smaller than what I'm doing the volume on, that is 27 over 8. So this had to be bigger. And I believe the correct answer is 9, 27 over 3 for the whole thing. And then there's another chunk that I need to take out. And I just I gotta go back. I gotta redo this. I know from past experience for some of these problems, you just gotta warm up to it with simple problems until you start hitting the harder ones. And I am much happier spending like 2 or 3 weeks on this alone at some point later than trying to spend a lot of time now when I'm just trying to finish the book. It's a cop-out, and I know it, but it has to be done. It has to be done. Simple proof, worked it out. Got some handouts on partition of unity. It's a tie-in to topology. I'm not going to show it here, but I have Moncrief's topology, and I read a little bit in there. It's actually a very interesting concept. Ties into a bunch of different concepts within topology, and it will require more reading. And I love topology. I'm actually really enjoying it. So these are just handouts I picked out. Then I started doing more problems for the remainder of chapter 12. Yeah, and those were the gamma function problems. And then chapter 13 reading. Chapter 13 is sort of a little bit of an applications chapter. It read very quickly just because of my own physics background. Straightforward as could be to just read through, you know, things like parametrizations. And of course, once I started looking at all these parametrization theorems, I basically had this in my mind, and the mapping of tau from j to I, phi from I to the final phi of I. But then when you do them together, it's really phi dot tau, convolution of phi and tau, and it's psi of j. Psi of j is equal to phi of I. And I just, as I kept going through, there would be other theorems that would be of the same concept, and I would just immediately draw that diagram. So as I keep going in here, you will see it again. Oriented curves, there it is. I just draw it. You know, it's like, okay, that's what we're talking about again. Got it. Yeah. Yeah, the whole business of change of variables as they're applied, as it's applied to different concepts. A little bit of differential geometry with one forms. I gotta do a little differential geometry someday, I hope. Oriented surfaces, different types of parametrizations. Yeah, the parametrization of a surface can be used to compute a normal to its tangent plane. Lots of parametrization concepts. Even put it into matrix form. See again, it's all about that diagram really from multiple angles. Yep. The Mobius strip, how to parametrize the Mobius strip. More about oriented surfaces. See again, the same diagram again, just different ways to hack it out. And then this business of dm dy minus dm dx came up at some point. Let me see where it is in here. And I got stuck in here. I couldn't tell when the way the author calls these things type 1 and type 2, where it's either y or x. I really didn't understand why this surface was broken into a half. I guess it's because of this little kink in here, but this is going to be someday I hope to ask somebody to explain this to me. And then gradient, curl, divergence, which I did a lot of in engineering. Grad diff, curl, various definitions of it. Lots of Jacobians. Kept trying to think about how the curl works out. An example. Yeah, grad diff curl. So this is good old vector calculus from engineering. And that was all of chapter 13.